Welcome to episode 72 of 100 Days of Data. I'm Jonas, an AI professor, here to explore the foundations of data in AI with you.
And I, Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
The father of modern computing, Alan Turing, is a name you've probably heard, but his impact on data and AI is foundational, yet sometimes misunderstood.
Absolutely. Turing's work is like the original blueprint for the digital age we live in today. Without him, data and AI as we know them might not exist.
To start, let's put Alan Turing in context. Born in 1912 in England, Turing was a mathematician, logician, and codebreaker whose ideas shaped the very concept of computing.
And he wasn't just an academic tinkering in isolation. During World War II, he cracked the Nazi Enigma code, which famously shortened the war and saved countless lives. That was applied cryptography, using data to solve real, urgent problems.
Exactly. But beyond that heroic chapter, Turing introduced the concept of the Turing Machine in 1936, which is crucial in understanding what a computer really is.
Right. And I think people sometimes confuse computers with just the machines we use today. But the Turing machine is a theoretical model, a kind of idealized computer, designed to help us understand the limits of what machines can compute.
That's a key point. Turing machines aren't devices you can buy. They're abstract mathematical constructs that define computation as a sequence of simple operations on data, processed step by step.
And that concept has real business impact. Think about automation in banking, for example, processing transactions or detecting fraud. Behind the scenes, it's all about breaking down big problems into smaller steps that machines can carry out methodically.
The other big milestone from Turing is what we now call the Turing Test, proposed in 1950. It's a way to consider if a machine can imitate human intelligence well enough to fool a person.
The Turing test is almost like the original AI challenge, right? It makes us ask, can a machine think? Can it hold a conversation that feels human?
Precisely. Of course, the test is philosophical as much as practical. It doesn't measure intelligence the way a psychologist might. Rather, it gauges whether behavior can be convincingly human-like.
And in today's world, we see echoes of that everywhere. Chatbots in customer service, virtual assistants like Alexa or Siri. These are all attempts at passing a sort of Turing test in their context.
Yes, though none are perfect, but the idea forced researchers to think deeply about what intelligence means and how it might be replicated or simulated in machines.
From a consultant's perspective, Turing's legacy reminds us why we build AI systems, not just to crunch numbers, but to engage, predict, and support human decisions. It's the human-machine partnership he envisioned.
That partnership also leads into the foundational idea of algorithms, step-by-step instructions to solve problems. Turing proved that any computable problem can be solved by an algorithm running on a Turing machine.
And that's the magic for business. Whether analyzing customer behavior in retail or optimizing routes in logistics, it boils down to algorithms processing data systematically, something Turing paved the way for.
It's fascinating that Turing's 1936 paper on computable numbers is still relevant today. It laid the groundwork for digital computers, which today handle massive data sets and complex AI models.
Exactly. And if you look at industries like healthcare, AI-driven diagnostics rely heavily on these algorithmic foundations. Without Turing's early theories, machines wouldn't function as intelligent assistants to doctors.
Another important but lesser-known fact is Turing's work on morphogenesis, the study of how patterns form in nature, like stripes on animals. Late in his career, he applied mathematical models to biology.
That's a great example of data and AI crossing boundaries. Understanding natural patterns through data modeling gives powerful insights even beyond computing, showing how multidisciplinary AI truly is.
Unfortunately, it's also important to recognize the social context around Turing. Despite his brilliance, he faced tragic discrimination due to his sexuality, which had profound personal consequences.
That's a bittersweet part of his story. It reminds us that progress in technology is also about progress in society. Diversity and inclusion shape who can contribute and benefit from advances.
Absolutely. So, to sum up, Turing gave us the theoretical foundation with the Turing Machine, posed the question of machine intelligence with the Turing Test, and proved that algorithmic computation is possible.
And in practice, his contributions unlocked the potential for real-world applications, from cryptography and automation to the AI systems we rely on today in various industries.
For listeners, the key takeaway is this. Turing's legacy is the blueprint for understanding what computers are and what they can do with data. His work bridges math, logic, computing, and AI.
From a business angle, knowing Turing reminds us why we build AI systems, not just for crunching numbers, but to engage, predict, and support human decisions. It's the human-machine partnership he envisioned.
Next episode, we'll explore another giant in the history of data and computing, Claude Shannon, the father of information theory.
Shannon's work is the bridge between raw data and the way machines communicate and process it. It's the next logical step after Turing's vision.
If you're enjoying this, please like or rate us 5 stars in your podcast app. We'd love to hear your questions or comments, which might appear in future episodes.
Thanks for listening. Until tomorrow, stay curious, stay data-driven.